morning, kiddos. We're going to learn our last new thing today. So if you will turn to page, can't see, 411, page 411. I'm going to at least introduce you to radians, okay? If you go on to college algebra, I don't want you to hear the word radian for the first time in that class. So what I'm going to do is just read through this. I want you to read along with me, and then we're just going to talk about it. The math is super simple. I just want to make sure that you understand the concept of it, okay? So let's just start at the top. It's just one page that we're going to go through, so this isn't going to take terribly long. Throughout this chapter, all angles have been measured using degrees, and we talked about that. I kept drilling, use the degree symbol, because it matters. A circle is broken into 360 degrees since this composite number has many convenient factors to use. However, another common angle measure exists that is based on the value of the radius of a circle. The alternate angle measurement, radian, you see that word in bold in your text there, divides the circle into pieces that are the length of the radius. This measurement links the angle measurement to the properties of the circle. The sequence of images below illustrate the creation of this type of angle measure. Okay, so let's walk through those. So you begin with a circle with a radius. Okay? Whatever size the circle is, okay? Doesn't matter. So we have a circle with the radius that we have named R. R for radius. At the end, okay, step 2, at the end of the radius, extend a tangent line that also has the length of R. So however long this is, you would have to measure it. Of course, I can't do it precisely, but we would make a tangent, not pretty, but you know, a tangent hits a circle at one point and one point only, okay? So that's a tangent. So the length of the tangent here, I would really like to make this look more perpendicular to the radius. So stand by. Because for those of you in geometry, you know that a tangent is perpendicular to the radius. So the length of the tangent has to be the same as that guy, okay? Now, what you have to do, and this is what we can't do, is to curl that length of that tangent, the length of R, curl it around, kind of wrap it around the circle. Okay, so if we could take this length and just wrap it around here, you know, hopefully that makes sense. So it just kind of comes in and we would wrap it around and, you know, I mean, it'll hit, I don't know, let's just pretend that it hits right there. And then we extend another radius, okay? So I know if I drew another radius right there, we know that all radii of the same circle are congruent. So I just connect. So if I were to take this tangent and curl it around or wrap it around the circle, wherever it would hit, I would draw another radius right there at the end of that tangent, okay? So I just created this nifty little angle right here. That is 1 radian, okay, for every circle, each individual circle. Okay, so now hopefully you just understand the concept of that, okay? You draw a radius, draw a tangent, the length of it, wrap it around, connect the end of that tangent back to the center with another radius. There's a radian. Okay, So back to the text, okay, back to the paragraph. Recall that the circumference of a circle is 2 pi r. Circumference equals 2 pi r. That's an old formula that you learned a long time ago. You could have also learned circumference equals pi d. Same thing, because 2 radii make a diameter. Okay. Well, you know that r is the radius of the circle. Okay. Pi can be 3.14. It could be 22/7. It could also just stay pi. At this point in your math game, most of the time, pi is just going to stay pi, just the symbol pi. All right, so where were we? I got to stop talking. Okay. Recall that the circumference of a circle, this is the formula for circumference of a circle, is 2 pi r, where r is the radius of the circle. Then a full angular rotation is 2 pi radian. Okay? So let's just keep reading. This sets up a convenient conversion between radians and degrees. One full revolution is 2 pi radians and 360 degrees. Same thing. Those two are equivalent. So 2 pi in radian measure is the same thing as 360 degrees. Okay, those are equivalent. So let's see, where are we at? The equation reduces to give the following relationship. Okay, so if I were to divide both sides by 2, okay, just to get pi by itself here, pi in radians would equal 180 degrees. Okay, so this is the reduced part of this is what we're going to be messing with today as far as our math goes. Okay, the simplified, reduced portion of this is what we're going to hang on to. Converting from one unit of measure to another is a matter of dividing by the appropriate unit. Dividing the above relationship by pi radians gives 1, okay, which equals 1/8 anyway. Okay, this is all like, it sounds confusing, but it's really not. Let's just dive into the math. So look at the little box. This will just make a whole lot more sense. Let's just go straight to this little box that says conversion factors, okay? This is where I want you to land. Okay, so here's what you need to hang on to. If you are going to go from degrees to radians, we're going to use this to convert. If we go from radians to degrees, we just flip it. Okay, so this rad right here, this is radians. This is comparable to our degree symbol, okay? It's not, once we start working with problems, it's not necessary to write it. It's just kind of a given, but that's what is identifying our units, okay? Either I've got degrees or I've got radians. Okay, so let's walk through the example. Let's see what I can get rid of here. Okay, let's walk through the example. 8.5a. It says convert the first part 108 degrees to radians. All right? So I'm going from degrees to radians. So that means I'm going to use this one right here. So I'm going to take 108 degrees times, and I'm going to do pi over 180. Okay, now, really simple thing for you to remember. If you remember doing conversion fractions, primarily in upper level sciences, if you're trying to convert, I'm not going to go too deep because I don't want to muddy the waters because some of you guys haven't gotten there, but there's just a really simple concept for you to take hold of. If I'm trying to get rid of, because you understand how fractions cancel, okay? I'm trying to convert degrees to radians, okay? So this 108 degrees that I've been given, like, you understand that that's over a 1. So when I say to you, I've got degrees in my numerator in this fraction, anytime you're wanting to cancel something, I would need degrees in the denominator, okay? Or if I had something in the denominator, in order for it to cancel, I would need it in the numerator, because that's how we cancel, right? We cancel up and down, or we cancel top and bottom, okay? So really all you have to remember is if I'm trying to get rid of my degrees, then my degrees has to go on bottom, okay? So I'm just going to kind of, let me put everything together. This isn't how you're going to do it, I know. But so if I were to just multiply these, I would have 108 degrees times pi radian over 180 degrees. Okay, so your calculator can do this reducing for you. What is that reduced here? 3/5. Your degrees cancel, just like every other unit does. And then all I'm left with is pi. And so you see that. And it may even look like, it may not even be in the numerator. It doesn't matter. It doesn't matter if it's on the top or if it's independent. Now, here's what I meant before when I said it's not necessary. This is telling me that my measurement is in radians, but writing it isn't necessary, unlike a degree symbol. A degree symbol is necessary, okay? But if you see just this, you understand that it is in radians, okay? So that's what I meant by it's not necessary, okay? It's not necessary for you to show it, okay? It's understood. That's understood to be in radian measurement. All right, so part B says to convert (7 pi over 12) 2 degrees. Okay, so times, all right, I'm going from radians 2 degrees, so I'm going to do my fraction this way, okay? You know, these are the same. You can use them however you want to. Like, for those of you that have had like physics and stuff like that, like, you know, 12 inches equals 1 foot, and 1 foot equals 12 inches. And you can use that to convert however you need to, whatever it is that you're trying to get rid of. You know, you just want it, like, if one's on top, you want it on bottom so that they cancel. So this is the same thing, okay? So I'm trying to go 2 degrees. So it's these pi's that I'm trying to get rid of, okay? This is in radians, and I need my radians gone, okay? So that's how you just have to remember that that goes on bottom. All right, so then we would do the math. I don't know what 7 times 180 it is. Okay, so whatever 7 times 180 degrees is, and then I forgot my calculator again, 12 pi, and that is in radians. Okay, we understand that there is radians there, but it's not written because it's not necessary. Okay, so those would cancel, your pi's would cancel. All I have left is degrees as far as units go, so let your calculator do that math, whatever that is, okay? Pretty easy math. So it would be 105. Okay, the math is really easy, okay? And even this is easy. It's the same. I mean, hopefully you recognize this is the same as this, it's just inverted, okay? Whatever it is that you're trying to get rid of, that just has to go on bottom, okay? If I'm trying to get rid of degrees and go to radians, I'm going to use it like this because my degrees are going to cancel. If I'm trying to go from radians to degrees, I'm going to use it like this, the reciprocal of it, so that my pi radians cancels, okay? So let's just do one of each on your problems. Okay, so, excuse me. So you're going to do numbers 1 through 24. Excuse me, on the next page. So let's just do one of each.
Ryan won't know if you can explain part A again.
We're fixing to do one. So turn the page over, and we're going to do, let's do number 1 together. That'll take care of part A. It'll be a repeat of part A. So number 1, you are given 30 degrees, okay? The instructions say convert the given angle to radians. It says without a calculator, but you can, as long as you set up your fractions and show me your fractions, you can use your calculator, okay? So, because you can use your calculator for the math part, okay? But I want to see you use this conversion fraction correctly, okay? So I'm going to go from degrees to radians, all right? So this right here tells me if I'm going to go from degrees to radians, I'm going to multiply this by the fraction like this, okay? And again, I've got degrees on top, so I know I've got to use the one where the degrees are on bottom so that they cancel out, okay? So I'm going to do this 30 degrees times pi radian over 180 degrees, okay? So your calculator will reduce these for you. That's the only thing, because this is over a 1. Right? So these will cancel. My zeros cancel. I know I've got, that leaves me with a 3 on top and an 18 on bottom. Your calculator can do all this. 3 goes into 18 6 times, leaving me with just a 1 on top. Okay. So if you punch in 30 divided by 180, it's 1/6. That's what your calculator is going to say. Okay. Now, I do have this pi radian left in my numerator, okay? So I can't forget about it. Okay, now, just to simplify this down, to make it as simple of an answer as possible, this pi doesn't need a 1 coefficient. I always understand that there's a 1 there. And again, radian, writing that unit out isn't necessary. So this could be reduced down. I mean, that's as simple as it gets, okay? That's not to say that this is wrong. It's not wrong, but this is the most simplified way to show that answer, okay? Again, because if I just have a pi here, I understand that there's a 1 next to it, okay? And without anything, without a degrees, I understand that it's radian, okay? So that is like part A, all right? So let's do number 13. That's the next section. And this is what we are given. We are given 2 pi, okay? And the instructions for that section say to convert the given angle 2 degrees. So I'm going from radian, okay? Even though I don't see that RAD right here, I understand that it is in radian measure, okay? See, it's not necessary to write it. So I don't want you to get confused because you don't see it, okay? Just like you understand that this is degree, okay? You just have to understand that this is in radian, okay? That's that pi. That's a dead giveaway, okay? So we're going to go from radian to degree, okay? So if you go over here and check your chart, to go from radians to degree, I have to multiply it by, and if you want to, you can stick that over a 1 to make it look like a fraction, if that makes you happy. We're going to multiply that by 180 degrees over pi radian. And again, this isn't necessary, okay? So I'm making those pi's cancel, okay? So this guy was on top, I need him on bottom. In order to cancel, I need him on bottom, okay? So those cancel. This I understood had a radian, they cancel, okay? Again, that's just the measurement. So now this is just really simple math. 2 times 180 over 1, which is just 360. And I put degrees. You have to put degrees. You don't have to put radian, but you do have to put degrees, okay? I know I've said it a dozen times, but I usually have to repeat myself a lot, all right? So that's it. Like, it is that easy. You're either doing this to get something in radian, or you flip it and you use it like this in order to get a measurement from radian to degrees, okay? So this is the same. I mean, you should recognize, again, that this is just the inverse of this, okay? It's the same thing, just in the same way you could set up 12 feet 1 inches this way or this way. They're equivalent to each other, okay? You just situate it however you need to make the right thing cancel, okay? We certainly don't need like degrees squared or something ridiculous like that, as if that's a thing, but you know. Okay, so if there aren't any questions, then I'll just cut you loose. This is the last new thing that we're going to do. It's all review from here on out, okay? So again, you can use your calculator to do the math part, okay? But like what you see on the board is what I need to see on the paper. I need to see how you set up your conversion fractions, okay? If you show me how you set up your conversion fractions, then you can use your calculator to do the math, okay? So just do it. I just want to see that you did it right, okay? All right. If nobody is speaking up, then we'll call it a day. Have fun. Enjoy. Enjoy the easy math.